So in this video, as you know, I'm going to design an AND gate using Cadence. I'm not a professional in this field, but I'm just a learner. In case you see any mistakes, feel free to comment. I don't know will anyone see or not, but if you are watching. So at first I'm going to the file, new. I'm going to open a new library, okay. I'm going to name it NAND Gate 1, okay. Then attach to the existing technology library, okay. GPDK 90, okay. Again, I have to create a new cell view. Let's name it NAND, okay. So we have successfully opened the Cadence. Now, I'm going to press the I from the keyboard and browse. I'm going to take PMOS. For PMOS, you have to select GPDK 090. There is NMOS. At first, I'm going to take NMOS. There is one NMOS. There is two NMOS. And same as I have to take PMOS. There you can see PMOS 1 volt. Here one, and here is another one. Now, same as you are going to select ground. For ground, you have to select the analog lead G and D. This is the ground. And same to same, you have to go for the VDC. Okay, this is the VDC. For the VDC, you have to select another ground. So I'm going to select G and D, ground. So now I'm going to press the W in keyboard. That means I'm going to take wire. Select this two. Mm, mm, mm. Okay. Why are you dancing? Acha. Now, okay. I have to mirror it, okay, because it will be easier for the connection. Mm. Okay, let's connect this two, and you have to connect this two with the upper side of this. That means to the VDC. And for NMOS, you have to connect like this one. And this one goes where these are gonna be input. Same to same. Here is another input. And here is another output. Sorry, another input. And I'm going to connect this two like this. So this is actually our main schematic. Now, oh, I forgot to connect the ground. Why are you dancing, bro? Okay. Okay. Now I'm going to press the P from the keyboard and going to take input. And I have to select input. Now this is one input and mirror. Again, I'm going to press P, another, no, let's name it B, input A and input B, okay? So I have to mirror it. Okay. Double click in the input and name it A. Now, these are actually same connection. That means these two are same input A. Mhm. These two are same connection. Okay, same to same connect the B. Allahu. What the hell? Where are you going? Hmm. So I have connected successfully the two inputs. Now I have to take two voltage. I'm going to press the I from the keyboard, and I'm going to write V P U L S E, V pulse. Here is one V pulse for the input B. Here is one V pulse for the input A. Now all you have to do, for the inputs, you have to take two grounds, same as I'm going to select the ground G and D. Here for one another, here for this one. Okay, I'm going to press the W for the wire. I've successfully connected the wire, and this upper side goes to the A input, and this upper side goes to the B input. Okay, I have successfully connected all the components. I forgot something. In here, you have to connect these two. You have to connect these two with the ground. Okay. Okay. Now, the voltage sources I have selected, I have to give them value. Okay. Without value, no one can survive. Okay, properties. Then I'm going to give it 2 volts, suppose. You can give 5, 3, 1, 1.5, whatever. Now I'm going to select it, right click it, properties, and I'm going to give it, suppose 1 volt, okay. And period, I'm going to give it 20 nanosecond, 20 nanosecond, and no delay time. Rise time, let's give it 5 picosecond. This one, fall time also 5 picosecond. And pulse width, I'm going to give 10 nanosecond. Apply. Okay. Same as for the A. I'm going to click, right click, properties, giving 1 volt. Delay time, I'm going to give it 40 nanosecond, because the other one I have gave 20 nanosecond. Fall time going to give 5 picosecond, same as the before, 5 picosecond. And sorry, this was the pulse width. Rise time 5 picosecond. And the pulse width, I'm going to give the half of the delay. So I mean 20 nanosecond. I've done with it. Apply. Okay. So I think I've connected all the necessary things. Let's do it. Oh, I forgot something, which is the output, which is the main thing of our circuit. From this point, I'm going to take the output. So this wire depends the output. I mean, this wire defines the output. Now I'm going to press the I from the keyboard, and sorry, not I. I'm going to press P from the keyboard and going to take an output. 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 Okay, and I'm going to select the direction as an output. So let's place in here. Select the mirror and select it. What the hell? কোত্থেকে এলো রে ভাই? Mirror it. What the? Okay. Now select this output and connect it in here. So this is my output. So I've done pretty much all the necessary things, I think. Now this is the main part I'm going to do, which is you're gonna click the launch ADEL. Now set up model libraries. Now double click the writing and select the GPTK 90 MOS SCS. Okay, open and double N click TTS1V. Okay, now you have to select the analyze, choose transient. TRAN means transient. So I'm going to give it 120 nanosecond and moderate. Okay. Now you have to take the output to be plotted. That means you are going to define the output and the input. So in here, this is my input A. See, this is input A selected. And this is my input B. See, this is also selected. Now I have to select the output. This is my output. Okay. Now I'm going to the same window again. So all you have to just same as before, simulation, netlist and run. So this is my output. I'm going to make it. Okay. Now split it. So this is my A input. This is my B input. This is my output. So as you can see, when A is equal to 1, B is equal to 1, suppose for AND gate, okay, for AND gate, that will be 1. But for NAND gate, that will be 0. Here is 0. Let's consider a difficult question. Suppose this one, okay. A is equal to 1, B is equal to 1. For AND gate, that will be 1. But for NAND gate, that will be 0. When A is equal to 1, but B is equal to 0, that means for AND gate, that will be 0. But for NAND gate, that will be 1. See, here is 1. I've changed a little bit. I have to show you. I've done something a little bit change. I've made a little bit change in this circuit, which is properties for the A source, the source connected in A. I was mistakenly written the period in delay time. Okay, so I've just edited it and added in the period. All you have to just 25 nanosecond in period and 10 nanosecond in pulse width, which is the source connected in A. Then okay. So that's pretty much all. This is the output. I think you have understood. As I already said, I'm not a professional in this sector. I'm just a learner. If you see any mistakes, in case anyone watching this video and see any mistakes, feel free to comment. I'll love to learn from you.